Hello and welcome to the Logs Story Problem video. This is the very last of the new material for this term, so this is a very exciting video. As you can see, we've gone back to the 4.6 notes. However, we're really just going over the first page because I wanted to show you that sometimes you're already given the equation in your story problems, and then I'll kind of handwrite a few questions. All questions from the Go Formative that we're doing are going to be pulled from sections 4.6 and 4.7 of our textbook. So if you have that, or if you want to take a look at the online version on Canvas, that's where they're going to be. So let's take a look at example 1. So let's see, suppose the formula d is equal to 5 times e to the power of negative 0.4 times h can be used to find the number of milligrams, d, of a certain drug in a patient's bloodstream 8 hours after the drug has been administered. When the number of milligrams reaches 2, the drug is to be administered again. What is the time between injections? So in this case, again, you don't have to build the equation yourself. Sometimes the equation is already built for you, but as we can see right here, this is our start. We're starting with 5 milligrams, we're ending with 2 milligrams, and our rate is decreasing at 0.4. So if we were to, solve, it tells us we isolate the exponential expression and then convert to logarithmic form. So when it says isolate the exponential expression, it means we need to deal with this 5. So we're going to start by dividing both sides by 5. I'm going to have 2 divided by 5 is equal to e to the power of 0.4h. And then from here, it's like, oh, yes, okay. So we have one base on either side of the equal sign. Now we need to rearrange. So here's our base. Here's our, exponent. And here's our answer. Now, when we rearrange here, since I'm dealing with e, I'm going to use a natural log. So I'm going to say this is natural log base e, an argument of 2/5 is equal to 0.4h. So again, this is base, answer, exponent, bacon and eggs, or in this case, natural log bay. So from here, we're going to keep solving. I need to get h by itself. So I'm going to divide both sides by negative 0.4. It's going to give me natural log of 2/5 divided by negative 0.4. I haven't written the base of e because we're dealing with a natural log, so we don't have to. And that's going to be equal to h. So I'm going to take this, plug this into my calculator, and I'm going to get that h is equal to, I'm going to go back there and say h is about, I'm going to use my squiggle equal sign, 2.291. Okay, but what does that mean? So now we have to write a sentence. We can say the drug should be administered after 2.291 hours. So really not too bad. I'm already giving you the equation. You solve using the skills we've already practiced. You write a sentence at the end. So not too terrible. So this next question down here is not necessarily for the story problem, it's just more solving. So I'm actually going to go through and come up with 2 equations for us to do, or 2 kind of half problems for us to do on our own, and then we'll just go to the Go Formative and practice. So hopefully this will be our shortest video yet. So let's see, I'm going to come down here. I'm actually going to write out the problem, so feel free to write this out with me. Let's see, if Tasha, and this is taken directly from 4.7. If Tasha invests $100 with an annual rate of 8%, compounded quarterly, how long will it be before she reaches $150? That should be a question mark. Okay, So, taking a look at this, let's see what we know. We know she's going to start by investing $100. So $100, that's going to be my start. Let's see, we know it's going to be an annual rate of 8%. It's compounded quarterly. Telling us that n is equal to 4. And then the question is, how long will it take? So what is the time before we reach $150, which is our end amount? So it's the t we're trying to figure out. So in this case, since we've been specified a certain number of times per year, we're going to be using the equation a is equal to p times 1 plus r over n to the nt. So taking a look, I'm like, oh, well, this feels like last unit. It kind of is. The story problems we're going to be dealing with, unless they're already given to us, like in the previous problem, is just going through and setting up the exact same equations we were using in our last unit, but now we're solving for the exponent. Now we're solving for t. So let's go ahead and do that. So if we're going to set it up in this case, we're going to say 150 is equal to 100 times 1 plus 0.08, our rate, divided by 4 to the power of 4t. So I'm plugging in everything I know, and then from here, I'm solving. So just what we normally do. So I'm going to do, let's see, I'm going to divide both sides by 100, and if I do that, I'm going to, let's see, 150 divided by 100, that's going to reduce to 3/2. It's equal to 1 plus 0.08 divided by 4 to the 4t. 0.08 divided by 4, it's 0.2. This is 3/2 is equal to 1.02 to the power of 4t. If you said that 3/2 was 1.5, that's also acceptable. So I take a look at this and I'm like, okay, t is in the exponent. I got to get it out of there. Let's rearrange. So here's my base, here's my exponent, here's my answer. This is going to become, let's see, I'm going to use log base of 1.02 of my argument of 3/2 or 1.5 is equal to 4t. This actually seems kind of like our last problem that we did. So from here, my calculator doesn't know how to deal with this base of 1.02, so I'm going to use my change in base formula to make sure my calculator does know how to handle it. We'll have log of 3/2 divided by log of 1.02. So again, that base became the argument in the denominator. Is equal to 4t. And then here I can divide both sides by 4, but that's going to give me a triple fraction. So instead, I'm going to multiply both sides by 1/4. And that's going to give me log of 3/2, or 1.5, over 4 times log of 1.02 gives me t. And once I plug that into my calculator, I get that t is about 5.119. I'm just rounding to the third decimal place. So what does that mean in this case? Well, it means that it will take Tasha 5.119 years to reach $150 compounded quarterly. So like I said, this is really similar to what we did in our last unit. So let's try something else from our last unit. And I'm going to pose the question of what if it was compounded continuously? What would that look like? Well, we're going to keep all of the same features. So we're still going to start. Oops, sorry, this should be in blue. Color coding, it's important. There we go. Okay, so we're still gonna start with $100. I guess I'm doing that up here. We're still gonna end with 150. We still have a rate of 8%. And we still wanna know what our time is. So let's plug all this in. So let's see, we're gonna have 150 is equal to 100 times e to the 0.08 t. I just realized I forgot to write the base equation, so that's going to be a is equal to p times e to the power of RT, or our PERT equation. So from here, I've plugged in everything. I'm going to start again by dividing by 100 on both sides. And if I do that, I get, oops, forgot to change the color. I get 3/2, or 1.5, is equal to e to the 0.08t. And this looks a lot like just our very first equation that we practiced in this video. So let's keep going. Let's rearrange base, exponent, answer. This will become, you can do log, I'm going to use natural log. Natural log base e with an argument of 3/2 is equal to 0.08t. From here, I'm going to divide both sides by 0.08 so that I get the natural log of 3/2 divided by 0.08. You can include the base e if you want, but again, you don't have to. And that's going to be equal to t. So let's see, t is going to be about 5.068. So if we were to write this in a sentence, I might say it will take Tasha 5.068 years to reach $150, compounding continuously. So it's okay to just write 5.068 years. I'm not going to have you convert that to like months or days or anything like that. And this is also why we spent so much time on the solving piece, because once you know you're solving, the story problems are just like, oh, okay, I set this up, and then we do what we normally do. So I'm going to leave this here for now. Take a look at the Go formative. Hopefully it's not too bad, and I look forward to seeing you tomorrow.